this modulating signal passes through the phase shifter block, the output of the 90-degree phase shifter block will be nothing but cos omega mt plus 90. Now please note that right now, to simplify the analysis, we are taking single modulating frequency. In practice, we will have the range of frequencies from 20 Hz to 20 kHz, and hence the 90-degree phase shifter that we have will have to provide the phase shift not just to single frequency but to the entire range, and hence it is called wideband phase shifter. It is called AF wideband 90-degree phase shifter. AF again stands for audio frequencies, and it is called AF phase shifter because it has to provide 90-degree phase shift to all the audio frequencies from 20 Hz to 20 kHz. Right now we have taken single modulating frequency. The output of this block will be cos omega mt plus 90. Similarly, let me consider the carrier signal in the form of cos omega ct. That's my carrier signal. It is 90-degree phase shifted and given to the first modulator, and hence the first modulator will take carrier in the form cos omega ct plus 90. So now if you look at the output of the first balance modulator, because balance modulator is going to multiply the two input signal, the output of the first balance modulator will be nothing but cos omega ct plus 90, which is the form of the carrier signal, and this will be multiplied with cos omega mt. And when you multiply two cosine functions, cos a cos b, we will get half cos a plus b plus cos a minus b. Now I'll neglect that half part. If you neglect that half part, then your output will be cos omega c plus 90 plus omega m, which makes it cos omega c plus omega m plus 90, which is a plus b form. And the second will be cos a minus b form. A minus b will give you omega c minus omega m plus 90 will remain as it is. So that's the output of the first balance modulator. Now let us write down what will be output of the second balance modulator. The output of the second balance modulator will be multiplication of the two inputs to the second balance modulator. The inputs are cos omega ct in its original form and 90-degree phase shifted modulating signal, which is cos omega mt plus 90. So if I again multiply, I'll get cos omega ct into cos of omega mt plus 90. And once again, if I neglect that half part, cos a into cos b will be cos a plus b plus cos a minus b, and that exactly turns out to be what we have written here. A plus b will be omega c plus omega m plus 90, and a minus b will be omega c. This time minus sign will go with both omega mt and 90, so we get omega c minus omega m t minus 90. So that's the output of the second balance modulator. All we now have to do is add the two signals that we have obtained using a block adder. When you add outputs of both the balance modulators, you can see that cos omega c plus omega m plus 90 is the common term in both the outputs, and hence it will be added and it will become 2 cos omega c plus omega m plus 90. When you try to add the second term, which is in the form of omega c minus omega m, let us see what is going to happen. Please observe that the second term omega c minus omega m is 90 degree ahead in phase plus 90, and the second term in the second signal is 90 degree behind in phase. So if I consider cos omega c minus omega m t plus 90 and cos omega c minus omega m minus 90, because this is 90 degree ahead in phase and the second term is 90 degree behind in phase, the total phase shift between the two terms, or the total phase difference between the two terms, is nothing but 180 degree. And we all know that when there is the phase difference of 180 degree between the two cosine terms, then both the cosine terms will be exactly same but opposite in signs. For example, if I have cos theta and cos theta plus 180, then cos theta plus 180 can be written as minus cos theta. So we have two cosine terms which are in the form cos theta and minus cos theta, and when you add them, their addition will become 0. And that's how output of the adder is only omega c plus omega m term. The second term adds up to 0. And if you now observe quickly, we have got only one sideband on the output side, and that too it is omega c plus omega m, which is my upper sideband. The lower sideband term gets cancelled out, and hence you can see that without using any filter we are able to suppress one of the two sidebands. The output is then passed through the power amplifier and it will be transmitted through the antenna later.